Okay, good evening, everyone. Welcome to our software engineering class for spring 2026. I'm Professor Ung-Sub Kim from the Department of Information and Communication Engineering at Dongguk University. Today, we are going to talk about one of the most critical topics in software engineering, software project management. Um, Software project managers, even the best technical ideas can fall without good management. So let's get started. Okay. Project manager. Project manager is essential to both of the software project. Okay. So this their responsibility include writing contract to win the project, recruiting the development team, writing performance review for the team members, communicating with the customer, and estimating cost, creating and maintaining the schedule, identifying and managing risk, and document project management plan. But the 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 you have to think about the most important point. Okay? Good management does not guarantee project success, but bad management almost always results in project failure. So, project manager must plan and schedule development and monitor progress against the time and budget and ensure the project meets its constraints and goals. So, project management activity consists of two main phases. One is project planning, and the other one is project progress. In project planning phase, project manager must establish the project constraints and make the initial assessment of project parameter. In this point, the project parameter is about effort, that is man months, how many men needed, or budget, how many resources we need, okay, and duration like a deadline, the month of development time, and risks, okay. So project manager initially access the project parameter before he or she starts the project. And also, project manager must define project milestone and deliverable. The milestones and deliverable is used for to monitor the progress of project. Okay? And while the project is on process, project manager first draw up the project schedule and initiate the activity according to schedule. That is the schedule, that is some kind of tasks, main tasks, and maybe some tasks must start earlier and some tasks need to be started later. So once you define or project manager define the project schedule, then project manager initiates activities that is they should be started initially, okay, and then she must wait because she has to wait till something is done or something or your engineer is doing something and make some results, okay. Then project manager review the project progress, and when project manager review project progress, then the manager need project milestone and deliverable. And that is if milestone matches the original plan or deliverable satisfy the original plan, then project manager assume that consider such thing, consider some activity is completed, so it's time to start another activity in the schedule. Okay, and while the project is on progress, then project timely revise the estimate the project parameters. sometimes project delay happen, sometimes some cost increases. So project manager revise the estimated project parameter such that um, he or she can reschedule. Actually, finally, the schedule, your project should be finished on time, on deadline. So, to this end, the project manager should revise the estimate of project parameter um, frequently. Okay, and sometimes if he need uh, project manager renegotiate the project constraints and deliverable. Sometimes the cost gets too high or something happen. So in this case, if he or she finds the project cannot be finished on time, then maybe by renegotiating some parameters, then she can finish the project on time. Okay, and also if problem arises, then initiate technical review and possible revision. Okay, so such that anyway the goal is project manager's goal is to finish the project on time, satisfying all the constraints or the goal of the project. Okay. Here I mentioned the milestone and deliverable. Milestone is recognizable something of software activity delivered at the end of each activity. That is, in software project, there's many activity you need to do, your team member or your engineering team have to do, or each team member has to do. Okay, there's many activities. So by checking milestone, project manager can see some task or some activity is completed or not. Okay, so milestone is used for checking the project activity completeness. Okay, deliverable is a project result. That is the result to the delivery delivered to the customer. Okay, and deliverable is delivered at the end of project. So if deliverable is ready, then you assume that and delivery is ready and delivered to your customer, then you assume that your project finished, completed. And if some milestone is ready, then you assume that some activity is completed. That is, you can start another activity. Okay. So here is some example. Maybe there's many activity in the project like a visual study, requirement analysis, prototype development, design study, requirement spec, and each activity has some milestone like a feasibility report, requirement definition, evaluation report, architectural design, system requirement. So if feasibility report is ready and done, okay, then you assume that as your board, project manager, you assume that the activity of feasibility study is completed. If likewise, if architectural design is completed, okay, is ready, design is ready, and then you assume that okay, the activity design study is completed. So milestone is used for monitoring and checking software activity, development activities, okay, activities completeness, okay. So then, what makes software management difficult? The one thing is the product. So the product is intangible. You cannot see and touch it, something. So, and you cannot see the interim result. That is, you should depend on some concept or some word. That is, something is done and software development process is normally progress. Okay, so because you cannot see anything, so that makes difficult to measure the software progress. Also, there's no standard software process. That is company by company. Some company prefer some order of schedule plan, and some other company use different plan. But there's nothing is wrong and nothing is correct. So every software plan process varies dramatically from one to another. That means as your manager, as your boss, there's uh, no correct process. Okay, so sometimes your plan must depend on your own experience. Okay, and this experience may match your new project or may not match. It may not good for your new project. So that is because there's no standard. So you must choose your own way of development process. So that makes software management difficult. Okay. Also, large software projects are often one-off projects. That is, you have 1 year, 2 year project, and if project is done and it's done, and you have to go to another project, and the type of project may be different. Okay, so that is your old experience of project manager may have good enough. Okay, you need to learn more. You need to challenge some more thing. Okay, for the every new project. Okay, that makes software management difficult. Okay, when you software design plan your software process, there are some principles like this. Okay, first you have to understand scope of project. Scope of project is just the boundary of project, or you have to define the level of project. Okay, also when you plan project schedule, okay, you have to involve stakeholder in the planning activity. Also, you recognize planning is iterative. That is, initial plan is not will not be used for all the time of your project schedule. Yes. In many cases, the schedule plan will be changed again. Okay, so you recognize such part. So when you plan schedule, then you have to avoid the tight schedule. Okay, maybe you have to consider some schedule will be changed. Your plan will be changed later, again. So your initial plan must consider such a situation. Okay. Also, you have to estimate effort, duration, cost based on what you know. Okay, and you have to consider risk as you define plan and adjust the detail while you're defining plan, and define how you intend to ensure quality, and describe how you to intend to accommodate changes, and track your plan frequently. That is a basic principle for software design process. So basic primary software design planning step is composed like this. First thing you have to do is establish project scope. That is, you have to describe a function and features that is delivered to end users, and you have to produce after this scope should be produced after communication with all stakeholders. Okay, and second step is feasibility study. That means you have knowledge about some technical your technical level, or some development environment, or operational environment. So if you have some technology, some knowledge, then you have to analyze your knowledge or your team's knowledge can solve the required thing for your project. Okay, so that is a feasibility study. So at this step, you have to identify what you can do for the solve some computational problem, some problem for project. Okay, and third step is to create functional and non-functional requirement. That is, actually when you define establish the project scope, you describe a function and features, and at the in the step first. Okay, but at the step 3, you have to create functional and non-functional requirement more concretely in detail. Okay, itemize functional and non-functional requirement. After that, you have to identify required resource for your project, And then step 5, at the step 5, you have to determine development methodology. Maybe your schedule will be plan and document style, or your schedule will be you will adopt agile schedule. Okay. Also, you have to choose a programming language. Actually, there's only one language will be used. In sometimes, one language will be enough, and but in other time, in some cases, in most cases, you may need several programming languages. For example, in client side, you have to use JavaScript or TypeScript, and server side, you have to use some kind of Python or Java language, or for database, you need to use SQL or some other big data, some language for managing big data, big database. Okay, so you have to choose a programming language, or and some kind you have to define some kind of tech stack. Okay, once then you can estimate cost and effort. Effort means how many people need to be you need how many people to develop or finish the your software project on time. Okay. Also, some you have to estimate some budget. Okay. And once this is done, then it's time to develop project schedule. And finally, not finally, after you have done developing a project schedule, then you need to analyze risks for your project. Okay, that is basic software design planning step. Okay, and here is step 1, project scope. Scope is defined by answering the following question: how does the software to be built into business context? What constraints are imposed? What customer visible data are produced as output? What data object is required for input? And what function does the software perform to transform input data to output? Are there any special performance characteristics to be addressed? So basic thing is project scope is just a basic thing of your project. Okay, something about what you need to do and what thing the customer want. Okay, and how much you will implement, and what is boundary of your implementation, how much resource you need. Okay, that is project scope. Okay, so here is some example online quiz system, like overview of project, objective of project, need for the project, and scope of system. That is all about project scope. In the project scope defining stage, you have to identify this kind of thing, like exit system, scope of system, and deliverable. Okay. And next step, once you identify project scope, next step is feasibility study. Feasibility study determine whether the solution considered to accomplish in the requirement is practical and workable in the software. Okay, so you need to analyze whether in the feasibility study stage, okay, you need to analyze whether the software will meet organization requirement. To determine, you have to determine your project manager must determine whether the software can be implemented using the current technology and within the specified budget and schedule. And your project manager should determine whether the software can be integrated with another existing system. After you did in feasibility study, build the requirement statement. That is second step. Okay. Third step including functional and non-functional requirement. Okay, so here is some example about the online quiz system. When you analyze feasibility, there are 4 categories. Okay, that is not typical. You can give more categories. Okay, so one is, but this is just an example. You have to analyze financial aspect. You have to analyze technical aspect, so resource and business feasibility, and and all of things um, you think you can do it or it's possible and there's some benefit, then that means you can start your project, okay? And then next step 3 is the create requirement. There's two types of requirement. One is functional, the other one is non-functional. Functional requirements describe what the software delivers. So here is functional requirement example. One is submit question, grade answer, something like that. That is about what system will do. Okay, that is functional requirement. And another requirement is non-functional. Non-functional requirement describes how a software should work and describe how the software development team should work. Okay, so here is the example about non-functional requirement. One is performance, like response time, processing time, security, user authentication, or access level control, and usability. Users will be provided with a complete user manual as a PDF. That is one example. Usability defines how easy system will be used. And capacity and scalability, availability will be also non-functional requirements. These kind of non-functional requirements is talking about how system will behave, not what, okay? And the fourth step is identify resources. That is this is written in Korean language, but this step, you have to see the current existing system where you will implement, okay? So you have to identify number of servers, state of the network, and some kind of structure, organization structure. So that is all about identifying resources. If this is done, then next step is you have to choose project development methodology. Maybe there's two types of methodology. One is plan and document, and second one is agile process. Okay. Also, you have to choose a proprietary programming language. Okay. Maybe you can use high-level language like Python, Java, Ruby, and that will shorten your development time. Okay. Or you can choose low-level language that will make you the low-level language make you adjust or control your software more detailed. Okay, like C language, assembler language. Using C or assembler language increase performance, like response time or execution time. Okay, so depends on if you want to develop or your server, your system is good enough, then maybe you choose high-level language that will shorten total development time, and that will require less number of engineers. But if you're working on very small system, and this system execution speed is critical issue, okay, and then maybe you have to choose a low-level language, okay, that can control your system in detail, okay. Also, you have to consider API availability for the target application. That is, if you have a good library API available, then maybe you use you choose the language that can use such API. Okay. Also consider experience level of language of your team member. If your team member, all of the team member knows Python language, okay, then it's okay. But maybe Ruby, if your team member doesn't know Ruby, then using Ruby language as a development language is very challenging. Okay, that's the option. Okay, and previously I have to talk about two methods: plan and document and agile. And just I'm going to explain basic thing about the plan and document development. Plan and document development is just like this. Before you start coding, okay, come up with a plan for project, detailed documentation for all phases of plan. That is, before you start coding, you schedule everything, okay? And while you're doing your project, your progress, your team's progress is measured against the plan. That is, you have plan and schedule, and you have to measure or monitor your progress is matched for original your plan. Okay. Also, changes the project must be reflected in the documentation. So every change needs to be documented. Okay. So goal of plan and document software development process is to improve predictability via extensive documentation. So that is, every change, every pace, every activity is documented. Okay, so this documentation will be used for later another project. Okay, and because you have documented every change, that so everything is monitored, every change, every progress is documented. So this documentation will be used for future plan, future schedule. So maybe uh, another project will make more correct, or will be your another project will make more correct. Okay, correct plan. Okay, more precise plan. Okay, can make precise plan because um, the every activity, everything happening is documented. Okay, so documentation should be written at all stages of development and include requirement, design, user manual, test instruction, and project plan. So everything is documented. So using this documentation, easy to make better plan, uh, correct or precise plan. Okay, so they will be helpful for your companies doing another project. Okay. Also, plan and document development, government has regulation to follow when acquiring new equipment. Such regulation requires length of specification and contract. That is, because you have all the document, all the plan before you start coding. So this kind of thing, you can, because you have all the plan, easy to prepare the lengthy specification of some equipment. So if you have plan and document type, okay, you are working on plan document type, then maybe it's better to working with government. Okay. Also, when you bid to get some project job, okay, then they require some kind of plan, okay, some kind of budget. So plan and document development require making in the plan and document development, project manager it makes some detailed plan that will be used for calculate estimate cost, okay, or effort for the project. So it's better to use this kind of plan and document development for contracting or bidding some government project. Okay. So in plan and document development, use scenario and use cases. Also, they are making software requirement specification, and this requirement specification must be traced after project is completed. So that is, your final result must fulfill all the specification, okay, all the item in requirement specification. Also, in plan and document development, the cost estimation is via project manager experience or formulas such as COCOMO, okay, and scheduling and monitoring progress using POT chart, okay. But the software project still may fail, okay, because they don't do what customer want, okay. They are late, they are over budget, they are hard to maintain and evolve, okay. And because plan and document type is good for working with some government, okay, working is make budget report, okay, easy to better to make budget and estimate the effort. But this plan is created before coding, and detailed plan is created before you start coding. So um, things can be changed all the time. Okay, anything can be changed. So maybe final result may not satisfy customer want, customers expectation, or they may be late because your schedule and actual real world may be different. Okay, so the project progress may be result, or maybe over budget. Okay, maybe the price is increased, or some new additional stuff comes in. Okay, so over budget. Okay, so project in plan and document may fail. Okay, here is some statistics. Okay, so here is you can see graph. The red is abandoned, terminated, green on time, and blue is late. As you can see here, half of project is late or over budget. Okay, on time, on budget, green. The rate is very small, 16%, 13, 10, 10%, very small. So that is most project progresses. Okay, most project maybe most project is different from what initially expected. Okay, initial expectation and final result, final schedule will be changed different. Okay, in most cases, in only 10% of projects on time and on budget. Okay, so this plan and this kind of a plan and document type is good for contracting, working with government, working with big company. It's good for that. Okay, and there's some benefit, advantage, but they have a high chance of failure. Okay, because everything is designed or scheduled in advance to actual activity, actual coding activity. Okay, so agile approach comes in to resolve this thing. Okay, so this approach embraces change and defect. Okay, developer continuously refine working in complete prototype until customer happy with the result. That is, they are releasing revision every week or 2 weeks, release something and upgrade something, and write test before writing code such that reduce mistakes, and customer can still understand what they requested. So anyway, Scrum, Lean programming, X programming is agile approach, and here's the one. You have a requirement, okay, and then each requirement, okay, and then every 2-4 weeks sprint, every time you need to build small level of requirement. In this case, initially you only have a requirement only. Okay, and basic plan. Okay, so and every 2 or 4 weeks, detailed plan, detailed schedule is created, evaluated, and you make some kind of actual software product. Okay, so that is Scrum. So that means initially plan and document type, you create some document and plan and start coding, you finish coding, evaluate it, and deliver customer. That's kind of one step. That is plan and document type. But in Scrum, you don't have to do that. Just initially you collect some kind of requirement and start coding, and every 2 or 4 weeks you make a plan, schedule only 2 or 4 weeks. Okay, and then every 2 or 4 weeks your team should provide some kind of workable result. Actually, the workable result is final result, just a working result. But this working result customer can see this kind of working result. Okay, so that is different from Scrum and other plan and document type. So focusing on plan and document type, earlier version of plan and document type is defined like this. Process is defined with a sequence of phases. First step is requirement gathering, and then requirement analysis, and then project system design, coding debugging, verification, operational maintenance. This is a sequence of phases. So before going on next step, each phase has to be completed. So that means phase 1, start phase 1, requirement gathering, and phase 1 is completed, start phase 2, and after start phase 2 is completed, start phase 3. It's like a kind of factory system. Okay, so this earlier version, and it's just simple. Okay, and this plan is easy to make. Okay, and this kind of earlier version of plan and document development type is called waterfall model. Okay, so like this, waterfall model means initially you start requirement gathering, and if this is done, you start the next phase. If this done, next phase is, and if you reach this phase, then your project is almost done, and if this done, your project is finished. Very simple and easy to understand and easy to make a plan. Okay, that is waterfall model. But there's drawback of a waterfall model. The drawback is you in the requirement gathering stage, your manager or your software team, management team contact your customer at this stage, and then after that your customer will get final result after this stage, and there's some kind of time gap. Okay, maybe 1 year, 2 year. Okay, so during that time, all this time, there's no contact of customer. So maybe customer may change their mind. Okay, may forget what they are saying, what they said. Okay, when the project started. So because the gap between initial stage and final deliverable, because the gap, customer may not satisfy the final product because there's too many gaps. Okay, so to resolve this problem, maybe there's some process is proposed like a spiral model, like a prototype. Okay, prototype give customer to understand what they want and engineer to understand how to build. That is this model is spiral model combines waterfall model with a prototype. Okay, so look at this picture here. Actually, this is a spiral, but if you roll out, then it's like a waterfall model. It's the same, but just a waterfall model process. You just roll down like this. Okay, so here frequently analyze risks and frequently here prototype here. So customer come here and check the prototype of system and check the system is going well or not. So frequently contact customers. So that will reduce customers' dissatisfaction of the final product. That is spiral model. So spiral model's characteristic is two factors. One is risk analysis frequently, and customer comes in and checking prototype frequently. Okay, so the waterfall model is about the kind of process from initial stage to final stage, and everything is goes like waterfall. But spiral model, frequently you add some opportunity of customer contact. Okay, contact opportunity or opportunity risk analysis. So they will make the possibility of this that will make less possibility, that will reduce the possibility of the customer dissatisfaction. Okay, and RUP, Rational Unified Processing, combines waterfall and spiral model. So it's simply like this. It's like a waterfall model. like inception, elaboration, construction, transition. That is like waterfall model. But during that time, in each stage, there's type of tasks called workflow like this, and some tasks working together. Okay, in waterfall model, phase one phase finishes, and then you start the next phase. But in this case, some phases it started working together and working together like business modeling requirement stage is uh, working together, okay, and implementation while you're making requirement implementation is started and testing stage is started before you finish requirement, okay, and this kind of step is about requirement changes and modeling changes. So in this case, like a waterfall model, but many phases have chances of working together. Okay, so that is relational unified process. So that gives some changes. Okay, opportunities of changes of business model, requirement, or testing. Okay, so also you frequently deploy your implementation even though you do not finish the actual all the project. Okay, so this deployment give a chance of your customer contact or feel your final product. Okay, so that is relational unified process. So I introduced several type of plan and document type, and I will introduce agile process type. Then question is plan and document process good or bad? Okay, that's good or bad point. Good point is plan and document type matches government regulation because it gives you for details of all schedules to make range specification, easy to make range specification for some equipment or some by month. Okay, also you can predict most of the things, budget, schedule, because you have detailed plan. Okay, if your company is big and has several departments, then it's good choice because department has its own role. So in plan and document process, many activities, okay, is separated and working together or working parallel. Okay, so and tasks can be easily distributed. Okay, and work well if your team is composed of experienced engineers. Definitely, the display and document process require detailed schedule. So to make detailed schedule, you need an engineer that can finish his own task at the expectation. Okay, but bad point is what if there's a long prediction? If that project will be delayed and overweighted. Okay, what if engineer does not have enough experience? That is, some tasks expected to finish in 1 month, but your engineer is not that experienced, so take 2 months. That is kind of late delay. Okay, they will make a late delay. If error found in previous page, should we go back? Okay, definitely you should go back and you have to fix it. Okay, what about first pages when we go back? Okay, wait or do some other thing. It's very hard thing, hard question because maybe there's some you find some mistake in requirement document. Maybe then required document can be changed or corrected. But if some project coding is some part of coding is done based on such a long requirement specification, then maybe we need to abandon all the code that is about that are about the long specification and wait. You should wait. Your engineer should wait until correct requirement specific will come out. Okay, so that will make delay. Okay, and what happens when customer change their mind? Okay, how about the customer requires new functionality at the later phases? That is, your plan everything and you are doing correctly on time, but suddenly new requirements comes in, even though you have only 2 months deadline. What will you will do? Okay, it's very hard thing because everything is finished and some of your software engineer is gone. for the next project, but you have new task to do functionality to implement, and what should we do? Okay, so that is the bad point. Okay, so that is if you have a good engineer, okay, and you have some kind of working with the government, okay, so the government has requires some kind of contract, and you're a big company, okay, with many department, then plan and document type will be good choices. But if your team engineer is not the experience, or your customer change their mind, or your product in my product market is changed rapidly, then in this case everything can change. New requirement comes in, and some expectation makes better. The expectation is long, changes. In this case, plan and document time will not be long. Okay. Okay, correct. Okay. And next step is, once you define your type of development process, agile or plan and document, using RUP or spiral model, whatever. Once you define that, okay, decide which process you will use. The next step is estimate cost and effort. Okay, we normally estimate the project cost twice. One is before we bid a contract. Okay, the other one is after contract one. So after software architecture is designed, so the task as well as effort can be easily identified. Okay, the project manager wants second estimation to be no longer than the first, because your company need to get some profit. Okay, so but customer will pay the first calculated amount, not the second one. Okay, so two methods make a margin around 1.3 or to 1.5 to handle estimation in accuracy or unforeseen event. And second one is make three estimates and use that information to make best guess. Okay, and there's two type of cost estimate method. One is experiment cost estimation. Project manager have significant experience, and he will be rely on experience to make accurate estimation. So, to be project manager, he or she should be working on more than 5 to 10 years. Okay, more than 5 or 8 years. That means the project manager have experience of 5 or 10 years. Okay, so definitely based on his or her experience, he can estimate the cost. Okay, or quantitative estimation method is available using LOC, line of code, or using function point, or process-based estimation, or COCOMO 2 will be one of them. Okay, so cost estimation, line of code, you estimate the line of code based on your experience. Okay, maybe this line of code depends on language. C or Java has different code size. Anyway, you estimate the code size, and you can analyze your engineer's output productivity. Okay, so here estimation line of size will be 30,000. Okay, and your engineer's product is, if 1,000, then salary is 4,000, then total payroll cost will be estimated like this. Okay, that is how to use line of code. Okay, this line of code estimation is based on some experience, major experience, maybe C, Java, whatever. If manager has some experience of coding, and then estimation line of code is not that big difference. Okay, but this line of code depends on language. Okay, depends on automation or coding tools. Okay, so, and code size is purely estimated from past experience, so that is not that correct, maybe. So another method is using function point. That is, function point measures software size by calculating functionality of a system. Okay, measure functional requirement in terms of business transaction, focused on what function is being delivered. Okay, so here is the example here. You have a system like this. Okay, then in this case you identify number of input, number of output, number of inquiry. Inquiry is about the database thing. Okay, internal logic file, number of interface, external interface here, external application interface. So external input is data entry coming from external to application. Output is data entry from inside to outside. Inquiry from data to generate output. Logic file interface is kind of thing, internal data used for generating output. Okay, so this is a 5 type of components, and you count them, and once you count them like this, okay, this system counting external input has 1, 2, 3, 4 input, output 3 output, 3 inquiry, 2 logic file. Then next time is for each inquiry identify it is simple to implement, average cases, complex to implement, and then you assign weight for each cases. Assume that you have input, okay, 2 input type is easy to implement, 1 is hard to implement, then give weight like this, and then you count weight, and finally you have total point, and finally you have 48 points. Okay, and after that you have this kind of list of question, and then you score by your own your own justification. You measure the score. Okay, you score for this kind of question, like did the user require response time? Oh, it's good. Response is important. Or what percent information enter online? There's no online, then 0 point. So you score from for the every question. Okay. So then, okay. So count is 48, and this number will be computed using this equation, and 26. Okay. So finally, total result will be 43 about the 63. That is function point. But this is just a number. Okay. So in this case, okay, you have to compare this score to your old project. That is, you have to measure function point for every your previous or the old project, and then compare function point, this function point to another old function point. Then maybe using this comparison, then finally you can estimate, okay, function point, your engineer's productivity, salary. Finally you obtain total estimation of cost. Okay, that is function point. Also, that is popular method, process-based estimation. It's simple. You identify activity, and this is man-months. Okay, and this is number of people joining requiring for the complete this project. Okay, so total will be like that. So this is the number of people. This is just duration. Okay, so total man-month is calculated adding all these things. Okay, so here I'm sorry. Okay, so okay. So by multiplying duration of activity with number of engineer, finally you have total number of effort, like a person months. Okay, so together you will then you summing up together you will have 46 person month. Okay, so that is how to estimate the cost. Okay, and also there's some another model for Hokomo 2, but due to the time limit, I will skip this model. Okay. And after you estimate total effort, the next step is scheduling and monitoring progress. In this case, typically people are using POT chart. And POT chart is a network graph with a rectangle node and lines. And lines typically are tasks to do. Rectangles are event or milestone. And finding critical path in the graph to determine minimum time to complete the project. And in this case, critical path is the longest graph path from starting point to end point. So here is the example. Here. Okay, there's tasks. Task expected time here, and milestone. Milestone is output, and this is a required thing to start this task. Okay. So that means created schedule requires requirement document, and final result will be scheduled. Test code requires source code, and result will be code test report. Okay, so this is the POT chart. Okay, and then here is the result here. Here, first one, requirement document will be this guy, and this is create result. And there's two by hardware, two tasks here, create schedule and by hardware. Okay, two tasks and create schedule by hardware like this. And rectangle is milestone, and this line is the task, and this is duration. Okay, so but some cases a task requires 2 or more milestones, but in this case only one milestone will be joined. So in this case we have dummy activity like this. There's no activity. This is just a dashed line. Okay, so in this case 4 and 5, this test code require milestone of 4 and 5 together. Okay, by using these two milestones connected using dummy activity. So here is the test code require source code and software installed hardware. Two things. Okay, test code require two things. So this guy requires two things here, okay? And then these are connected with a dummy line. Okay? So that is the POT chart. Okay? So using this POT chart, you can simplify. You can see total schedule easily because this is graph. Also, by using this POT chart, you can estimate some kind of critical path. Also, in this case, how many people, if schedule is estimated like over, will be delayed. Okay, in this case, you can estimate how many people you may need to meet the schedule. Okay. So final step is and you have to analyze risk. Risk is identified with three categories, like technical risk, organizational risk, business risk. Technical risk is about technical aspects, okay, like choosing database cannot scale well, or choosing programming language cannot support something, or choosing some server limit, capacity limits, so some point, okay. Or organization risk is like members are not familiar with J2EE. business risk by the time project company's products is not competed to the market. It's business risk. You have to identify risk, and after you identify risk, you have to manage as your boss. You have to manage risks. Ask everyone about what cases, collect them, and build a risk table. Okay. So here is risk table. You have identify risk and rank them. Identify risk like this, and you have kind of probability and impact, and then you can by multiply this impact with the probability, you can estimate the expected cost. Okay, and then this risk will be ordered from large value to small value. Okay, and then you can make some action before you start your project. Okay, so like a toolkit delay delivery, and then you have to weekly checking and because changes and bi-weekly deliverable. Okay, so maybe bi-weekly deliverable means customer can see deliverable for every 2 weeks. Okay, so lose team member, pair programming means two-man team, and if one man is gone, then remaining member can solve the same problem. Okay, that is two-man pair programming. Okay, that is risk table. Okay, so risk handling strategy, risk management is risk reduction, acceptance, avoidance, protection. Okay. So risk reduction is to cover potential risk in the plan. Risk acceptance is to live with the risk to nothing. Risk avoidance is to eliminate risk. Risk protection is employed for tolerance strategy. Okay, that is 4 risk management types. So for every risk, you can use this strategy. Okay. And there's 10 students risk item and management skill, like not having latest version of other people's work. Then use GitHub effectively. Okay, so you can accept, you can get some other people's work. Lack of experience, and maybe take time to learn tool, help watching YouTube or using the AI. Okay, being overwhelmed by work in other classes, update for main plan frequently, common meeting time in the beginning, determine all possible common available time. So the first thing is as a manager or as a team boss. Okay, you have to identify risks first, and then maybe you have to provide some solution for such risk. If such risk happens, then using risk avoidance, risk reduction, whatever. Okay, you have to prepare the strategy for risk happening. Okay. So this is done of software engineering classes, and thank you for attending my class. And this is the final material to be covered for the final exam. Okay, and good luck for final exam. Okay, and have have a happy vacation. Okay, thank you.